So now we're going to be doing kinematics problems, and it's going to be like harder than this on the AP and on the test, but this is for you to like grasp the ropes, and these are just like the most basic of kinematic problems. Once we cover things like relative velocity and motion in two directions, we will be doing slightly more complicated problems. Either way, today's problem, we have you throw a ball straight up with a velocity of 10 meters per second. How high does the ball go above the throw point? Alright, so for these kinds of questions, like, it might be helpful for you to like draw a visual representation of what happened. Say that this is you, alright? And then you throw a ball from this point, which we shall call x equals 0. Throw it up, and it reaches the highest point before coming back down. And we're going to assume that it goes in like a straight vertical line into the sky, because we haven't done motion in two directions yet. The question is basically asking for what is this distance, from the throw point to the very top. And after you finish drawing your diagram, you're going to want to like write out all of the parts that you know. So it already tells us that like the initial velocity is 10 meters per second. And then in free fall questions, the acceleration is always going to be negative 9.8 meters per second squared. And then our last few things that we have to look for are going to be time, displacement, and final velocity. So, like, looking at this question, we don't have a time that's going to be given to us, and we're not looking for time, so you can throw that out the window. And then for displacement, we are looking for displacement, so we could write x equals question mark. And then for final velocity, we're going to have to imply it. So if you know how to get velocity from a position versus time graph, at the top of a parabola, like this, at the flat part where the tangent line is 0, when the slope, or velocity in this case, is going to be 0. So at the very top right here, it's basically just like a very flat parabola, like that. At this point, right up here, it's going to stop momentarily. And then in our case, the final point is that point. So then we can say that the final velocity is 0 meters per second. But now we've implied and then figured out what we're looking for. So we're just going to look at the equations and see which ones we can use. So if we go here, let's look through them, and then equation number 4 is going to be the best equation because it contains like everything we have here. So I'm going to write that out. Then let's just plug in all of our numbers. And then if we solve that equation, we get 5.1 meters. And that's how you do these kind of questions. Alright, see you guys next time. And if you have any like questions, just like comment down below. I should have said that before I said see you guys next time. Okay, whatever.